guys. Are you able to see my OneNote screen, right? Guys, hello?
Yes, sir.
So in the last class, we said this particular thing: whenever the object starts its motion, whenever the driving force, the external force, is greater than the limiting friction. Then the object starts accelerating, right? Yes or no, guys?
So yes.
ये अपने last class, we already discussed this thing in the last class. And when the object starts accelerating, the nature of friction static to kinetic. Is this clear, guys? The nature of the friction changes from static to kinetic. Full stop. After this, whenever this nature changes from static to kinetic, it becomes constant. Once the object is set into motion. Is this clear, guys? It will become constant, it will not arise. One point you need to write: generally the value of or the magnitude of guys, are you writing with me? Please write with me, Anna. Of kinetic friction Fk is less than the limiting value of friction okay. Generally the magnitude of kinetic friction is less than that of limiting friction. The reason behind is because when the object starts moving or starts the motion, then the number of interlockings between the object and the surface becomes a little less. So have you seen this thing, guys? If there is a block which is at rest, so initially you will have to apply very large amount of force to bring that thing into motion, right? Once that thing becomes in motion, then what happens? You then pulling it or pushing it is easier, right? Why is it so? Because friction. Because of friction changing its nature from static to kinetic, the number of interlocking formed between the object and the surface becomes a little bit less as compared to when it was the limiting friction case. So basically it becomes lesser than the maximum. Okay, is this clear, guys? Is this clear, guys?
Yes, sir.
If kinetic friction is not mentioned in the question, Please remember guys, if kinetic friction is not mentioned in the question, then we can take kinetic friction basically equals to the limiting friction. Are you getting my point? If kinetic friction is not given in the question, then the limiting friction will be taken as the kinetic friction. Is this clear? Is this clear, guys? Do you remember the cases when I gave, the force and force graph? If I try to draw these graphs between the capital F and small f. So let's say on the y-axis I have capital F, and let's say, x-axis I have capital F, the driving force, and here I have the frictional force. So see guys, initially when the force is 0, then the friction is also 0. I'm drawing for two different diagrams. This is the diagram when kinetic friction is basically less than the limiting friction, or basically kinetic friction is given in the question. And I'm drawing this case when kinetic friction is not given in the question, and you need to take this thing as your limiting friction as the kinetic friction value. So can you see initially in both the cases when the force is 0, the friction is also 0. When you start increasing the force, what happens? When you start increasing the force, can you see this will be 90 degree, this will be 45 degree, right? Why it will be 45 degree? Guys, why will it be 45 degrees? So initially this will be 45 degree. Why it is 45 degree? Because the slope should be equal. So till the external force doesn't become equals to the limiting friction, till the external force doesn't become equals to the limiting friction. Can you see this is limiting friction? These two are equal. Is this clear, guys? Till here the object will be at rest and the nature of friction will be static. Then what happens when limiting, this kinetic friction is given to you, then at this particular thing, the object is just about to slide, right? So the kinetic friction decreases a little bit. Can you see it decreases a little bit, and then it becomes constant. So where is this constant? Where is this constant, guys? It is constant at F is equals to F. So basically somewhere over. Are you getting my point, guys? So there is a small kink in the graph which basically tells the value of kinetic friction has decreased a little bit. If it is not mentioned, then it will become constant over here in. So can you see the two graphs? What is the difference between the two graphs? So please draw these two graphs. What does this small kink in the graph represent? the graph represent kinetic friction is less as compared to limiting. Here in this case it is not, because there is no kinetic friction given in the question, right? So basically the limiting friction will be chosen as, so here the limiting friction will be chosen as the limiting of the kinetic friction. So always remember guys, it depends whether this kinetic friction is given or not. Is this clear? Is this clear till here? Guys, is it clear till here?
Yes, sir.
Nice. Guys, I'll just whenever you finish, just tell me. Guys, are you done? Hello.
Yes, sir.
Sorry. So this was the graph between friction. I told you about the different natures. The last kind of friction is basically called as rolling friction. Rolling friction is basically a friction which will come in what? Which chapter? A rotational motion. So this kind of friction comes. This friction appears when one object rolls over another object. Or rolls over another object or surface. Is this clear, guys? Can you see the difference? Guys, is this clear? Rolling friction. Please remember, this rolling friction can act in whatever direction it is possible. Okay. Is this clear, guys? Hello. Guys, is this clear? I'm not writing some more parts in this. We'll come back to this when the respective chapter will be there. Now we'll see how to guess the direction of we need to discuss the direction, right? So first case, when the object is moving with certain velocity over another surface. So let's do it case by case. Case one. So can you see a block and a surface, right, guys? This block is placed on the surface, but do you know our habit is to draw them separate, right? So that it will be clearer. These two surfaces are in contact with each other, but can you see I'm drawing it a little bit above, so that at least I'll get to know where exactly is the friction acting on which surface, right? So let's say this block is moving towards right. So yes, and the surface is at rest. So can you see the velocity of the surface is 0 and this object is, let's say, moving towards the right. Okay. Hello guys. So now what is the tendency of this object to move? बंद कर यार, wait. Just give me 2 minutes. Hello. Hello guys. So can you see over here this thing? This object is moving towards right. So tell me, with respect to this surface, where is this object moving towards, right or left? The surface is at rest. If the surface is at rest, then with respect to this surface, this object is having a tendency to move towards right, or it is moving towards right. Yes or no? So what will be the direction of friction offered by this surface on this block? So can you see this surface will try to hold back the motion by applying a friction in this direction. Is this clear? So this surface will offer a friction in this direction as this block was moving towards right. Is this clear, guys? Yes or no? The same friction which the surface is applying on the block will also apply on the surface, right? For every action there is. So the same F will be applied on the surface as well. So this will be the force of friction on the surface. Okay, is this clear, guys? The red one is basically what? Frictional force, friction on block due to surface. And what is the blue one? Get one. Friction on एक
So
yes. Tell me.
So done.
Done. Done. So is the case one clear? Acha, what if the object was moving towards right? Then the red one would have been towards left and the blue one should have been towards right. Yes or no? Yes or no, guys? Hello. Case two. If suppose I am giving you a case, this block is on another block, and let's say this block is on ground. I'll just draw to perfect rectangle. This is one. Control C, Control V. थोड़ा सा बड़ा, and I'll just place it over here, and this is the surface. Is this clear, guys? So let's say at any one particular instant, this has a velocity of 5 meter per second, and this has a velocity of, let's say, 2 meter per second. This is block A, this is block B, and this surface is smooth. If this surface is smooth, so will there be any friction between B and this ground? Will there be any surface between B and ground? Hello? Guys, hello, hello.
Yes, sir.
Will there be any friction between B and the ground?
Yes, sir.
Yes, sir.
Ground is smooth, I told you. This is your ground. ये smooth लिखा है ना यहाँ पे. The ground is smooth. Will there be any friction? Will there be any friction if these two are smooth? Guys, will there be any friction if B and ground is smooth? This is smooth, right?
No, sir.
So there is no friction over here, but there will be friction between A and B. So now you need to draw the direction of friction on A due to B and friction on B due to A. Okay? The red and one again, red and blue one. F is the friction on A. Please remember they will be equal, right? Because they will be action reaction steps. And the blue one, FBA, will be friction on B due to. You just need to draw the direction. Okay? So tell me, can you see over here? The velocity of this is 5 meter per second. The velocity of A is given 5 meter per second and B is given 2 meter per second. Both are towards right, yes or no? Always remember, friction opposes relative motion. It doesn't opposes the motion, it opposes only the relative motion. Is it clear? Hello?
Yes, sir.
So basically, what is the velocity of A with respect to B? What is the velocity of A with respect to B? Is it plus 5 minus plus 2? Yes or no? So is it equals to plus 3? Yes or no, guys? Yes or no? Is it plus
Yes.
3 meter per second? So can you see, if I talk about, if I say that, this object B is at rest, then A is moving over B with a velocity of 3 meter per second. So this is VAB, yes or no? So can you see, relative to this block B, A is trying to move towards right, yes or no? So hence this B will try to oppose this relative motion by applying a force on A like this. Are you getting my point, guys?
Yes, sir.
And similarly, the force on B
Yes,
due to
sir.
A will be in what direction? I have drawn everything with. So this is your F. Force on B due to A. this is force on B due to A. Is this clear, guys? Is the direction of friction clear? Is the direction of friction clear?
ये लॉज ऑफ मोशन ही चल रहा है ना?
हाँ, ये लॉज ऑफ मोशन के बाद में जो फ्रिक्शन पार्ट है ना, इसमें वो चल रहा है.
ओह अच्छा. Yeah, fine, so it's clear.
चलो, is case 2 clear? अच्छा, if I give you case 2 like this again, if suppose A block is there and B block is there, sorry, control Z. They are in contact, but it's not looking. That doesn't mean that they are not in contact, है ना? So this is again your smooth horizontal ground. Now, in spite of doing that, let's make it rough horizontal ground. I'm giving you just 2 examples so that you will be able to draw the direction of at least friction correctly. So this is rough horizontal, and let's say this object B is moving toward, this is rough ground, and this is moving with a velocity of 4 meters per second. Let's say this is, Hanji, tell me what will be the direction of friction on A, B? Where will be the friction existing? Will it exist between A and B? A and B
Yes,
are rough. A and B are
A
rough.
and B.
Okay.
And BN ground.
B and ground as well. So basically, you need to draw the diagram for 2 different frictions. Okay. Please do it. How will you do it? Can you see? Can you see it relatively? B is moving relatively fast as compared to A. Yes or no? So A will try to. Can you see the velocity of B is more? Hello, guys. Can you see the velocity of B is more towards right? B is faster as
Yes,
compared
sir.
to A, right?
Yes, sir.
So basically, A will try to oppose the motion of B by applying a force. By applying a force. FBA in the backward direction. Yes or no? Yes or no, guys?
Yes, sir.
And similarly, the same force will be applied on A as well, but in what direction? In the forward direction. So this will be FAB. So for every action there is equal and opposite reaction. Now ground is at rest. Yes or no, guys? Is the ground at rest? Hello, guys, is the ground at rest? If the ground is at rest, that implies this block B is now trying to move towards right with respect to ground. So basically ground will apply a force of, so this will be the force on B due to ground. And similarly, in spite of using some other color, can I use some other color? So this is the force on B due to ground, whereas the same force will be applied over here. So this will be the force on ground due to block B. Is this clear, guys? So can you see in this case how many frictions are acting on this block B? But can you see the direction guessing part? Is it clear, guys? Direction guessing part? Hello.
Yes, sir.
Can you see over here, guys? In this case, this friction and the direction of velocity is one and the same, right? The direction of friction and velocity is same. So can you see in this case, A will accelerate, B will decelerate. Yes or no? Can you say this?
Huh?
A will be accelerating because this friction will be producing certain acceleration on this block, right?
Then FBA is also there, no?
FBA is acting on B. Can you see FBA is acting on B, which is opposite to this velocity. So FBA will try to decrease.
So which is greater, FBA or FAB?
Are they greater, or is there any difference? Like one is greater, one is.
The velocity is greater.
What?
The velocity of B is greater than A.
हाँ, तो velocity doesn't matter, bro. These two forces are equal, no? Are these two forces equal? FAB and FBA are equal or not in magnitude?
Yeah.
But can you see the direction of this particular FAB? FAB is basically the red one. Red one. Is this force FAB is acting on A, right? And what was the direction of A's velocity? It was towards right. So this FAB is supporting the motion, but opposing the relative.
So why is FBA that side left?
What is the velocity of ये बता चल. What is the velocity of A with respect to B? Tell me.
Or 1 meters per second.
A with respect to
3 meters per second. 3 meters per second.
So A is basically +1 minus +4. So it is basically -3 meters per second. Yes or no? Is it clear? Velocity of A with respect to B. Can you see A is trying to go in the negative direction as compared to B? So when A was trying to go in the negative direction, that is why the friction was acting in the positive direction. Similarly, velocity of B with respect to A is basically +4 minus +1, which is basically +3. So B is trying to go towards right. That's why the force on B is acting towards left. Is this clear? Is this clear, guys?
Yes, sir.
Maybe अब समझ में आया ये दोनों जो forces हैं, they are action reaction pair यार. They are acting on different objects. But can you see A पे जो force लग रही है friction, it is supporting the velocity. It's in the same direction as velocity. Whereas B पे जो friction है due to A, it is acting in the opposite direction of velocity. So this friction FBA is opposing this 4 meter per second or opposing the motion, whereas this small red FAB is basically supporting the motion. But both frictions are opposing the relative motion. So that is why when I started in the beginning, I told you, no, friction always opposes the relative motion. It never opposes the motion. It opposes the relative motion. Is this clear?
So A is going to move left side, right?
हाँ, A is still नहीं, A is moving towards right.
If I can understand
This
the
is the
friction for A
tendency.
is on the right side.
बेटा ये tendency है. इस instant पे I calculated the velocity of A with respect to B. At this instant, when their velocities were given, this was the velocity of A with respect to B. मतलब if we say in the frame of reference of B, the object A was, had a tendency to move backwards. Can you see -3 meter per second? With respect to B, this object A is having a tendency to move backward. That's why friction is acting in the forward direction. Is this clear?
Yes, sir.
थोड़ा बहुत क्या समझ में आया देखो?
Sir, A will move backwards because in velocity is in negative.
A will have a tendency to move backwards on B. Because can you see with respect to B? With respect to B.
Yes, sir.
So that is the friction जो लग रहा है वो आगे की तरफ. So I guess the direction of friction is pretty much clear to you. Is it clear? The same thing you will do with the help of force as well. And even if your direction of friction is wrong, then automatically the answer will come with a negative. So never ever worry. Okay? Is this clear, guys? When the object is moving with certain velocity over another surface, case 1, case 2, case 3 done. Is this clear? So here I can write the friction note. The friction on A due to B is acting in same direction as velocity. Okay. Hence, it's supporting. Hence, friction on A is supporting the motion. But it's still opposing the relative motion of A with respect to. So our definition of friction was this only. Friction is a force which always tries to oppose the relative motion between two objects. So that is why, can you see over here? It is supporting the motion actually, but it is opposing the relative motion. Please write it. Done. Yeah, exactly. Whenever you're done, just tell me.
So done, sir.
Okay.
Could
So
you early today?
why?
Sir, boss.
So
Sir, appreciation.
I appreciate you people a lot. Don't worry. My lots of appreciation with you people. आज जाना जब 8 बजे क्लास खत्म होगी. Do party and all. No, don't worry. तर आज की खुशी में 10 minutes early break. Okay? Happy?
Thank you, sir.
But guys, वो 10 मिनट में तुम क्या करोगे घर पे? What can you do in
सो
those
जाऊंगा.
10 मिनट में सो भी जाओगे. Very good.
So power nap, sir.
So anyways, guys, the same thing can be used with the help of if forces are acting on the blocks. Forces are acting. Then always look to the tendency. Okay. So if forces are given, then always look for tendency. For example, case 1, if I give you, there is this object and I have applied a force F on this direction. Let's say initially this object is at rest. This object is not even moving. Can you see, guys? This object is, let's say, at rest and I have started applying a force at t equals to 0. Will there be any force? Will there be any frictional force on this object? Will there be any frictional force acting on this object? Can you see this object has a tendency to move towards? Hello? This object has a tendency to move towards?
Sir, right.
So hence the friction on it will act towards.
So friction is 0.
Why? If force is कुछ लग रही, let's say 15 Newton लग रही is force. At t equals to, at this instant I am asking. Does it have a tendency to, I'm not asking you about the magnitude of friction. Friction, that will be depending upon if this is at rest. But can you see still it is 15 Newton?
No,
Can you
sir.
see still it is 15 Newton? है ना? Depends upon what is the limiting friction acting at this instant, we decide whether the friction will be zero. Can you see? Friction will be zero only when this driving force is zero. But this driving force is something. Although it is at rest, friction will be there at t equals to 0. It will start with certain acceleration, right? If FL is less than. So the point is not about the magnitude. The point is about the guessing of direction. Can you see the tendency of this object is moved towards right? Yes or no? So what will be the direction of friction acting on this block? The direction of friction will be towards left. By this surface, a friction towards left will be offered in this block, and by this block, a friction on towards right will be offered. So can you see, whenever there is a force acting, you always see where it is tending to. Is this clear? Is this clear, guys? Is this
Yes,
clear?
sir.
Hello? So we'll see some questions in which there are more than two forces are applied. Let's say on the upper block also, lower block also, there are certain forces. Then we'll see how to deal with those type of questions by doing certain questions. So I hope till here the direction of friction is pretty much clear to everyone. I'm not discussing each and every case over here. We'll discuss some questions with the help of. We'll discuss the further concept with the help of certain questions. Shall we start? Guys, shall we start?
Yes, sir.
So now suppose I need to calculate the friction. I need to teach you how to calculate friction. Please keep the heading. Laws of limiting friction. The law of limiting friction. We know how to guess the direction of this thing. The direction of friction, we know how to guess it, right? Now, if I can find out the value of this limiting friction, then most of the problems will be done. So how to calculate this limiting friction? It is using this law of limiting friction. What does it say? It says that the friction, the value of limiting friction, basically the maximum static friction. So the value of limiting friction on an object directly depends on directly depends on किस जगह पे you can add is directly proportional to the normal reaction acting on it between the two surfaces in contact. So always remember, suppose if this is an object, this is the case, and let's say I'm applying certain force. So there will be certain friction acting, and we know how to give the definition to this limit. If whatever is the limiting friction, it depends on this normal reaction. This, can you see this normal reaction which is acting on this object? So always remember, and the same normal reaction will be acting on the surface as well, but we don't care. The same friction will be acting on this surface as well, but we don't care, right? We don't require this, we don't require this, we just require this. Okay, so the limiting friction value is directly proportional to the normal reaction, and when this sign of proportionality is removed, you introduce a constant. That constant is mu. Do you remember 9th grade refractive index mu? Hello?
Yes, sir, for wavelength.
Wavelength nahi, for refractive index, wavelength was lambda.
Oh, yeah.
So anyways, this is mu, where this mu s is called as the coefficient of static friction. Coefficient of static friction between the two surfaces. Okay. Please remember, this is a constant of proportionality. It depends on two things. It depends on the roughness of the two surfaces in contact. And the second thing, it depends on the material. The two surfaces, if I say, it depends on the roughness of the two surfaces of contact. So basically, whatever factors which can affect the roughness of the two surfaces, that will be affecting the static of, affecting the coefficient of static friction. Is it clear? Is it clear, guys? Hello?
Yes, sir.
So always remember, हाँ बोलो बोलो.
Clear है sir. Clear है.
Okay. For an object to be at rest, the friction acting on it should be less than the limiting value. If you remember, I already gave you this thing, right? The friction should always be less than the limiting value. Is this clear? Yes or no, guys?
Yes, sir.
Guys, whenever you're done, just tell me. So what are the two friction? Friction is dependent on two factors, right? One is this mu s. Basically, it depends. Mu s is something which is related to the roughness between the two surfaces, right? And can you see over here, guys? Guys, can you see over here? Please note, mu s is nothing but limiting friction divided by normal reaction. So can you see force upon force? Yes or no? Can you see force upon force? So hence, coefficient of friction is, what is the unit? SI unit. SI unit is none. It's dimensionless. Dimensional formula? None. It's a ratio. Please remember, it is a ratio. It's a dimensionless variable. Is this clear, guys? ये सब लिख लिया हो तो अपन आगे बढ़े. Are you done with this? Guys, are you done with this?
Yes, sir.
Okay. So this is your formula mu s, and ये सब याद रखना बस. Simple if f is basically mu multiplied by n. The same thing we can come to the same laws we can apply on kinetic friction as well. Even kinetic friction also depends upon both these two terms, but you know this kinetic friction, when we remove the sign of proportionality, we don't introduce mu s over here, we introduce mu. Well, what is this mu k called? Mu k is called as the coefficient of kinetic friction. Generally, this mu k should be less than the static friction coefficient of static friction. Do you remember this thing, guys? Generally, Fk is less than the limiting value of friction, yes or no? I told you, this thing, kinetic friction is less than limiting friction. So can you say mu k into n is less than mu s into n? So can you see? Mu k is less than mu s. Static friction is the greatest. Kinetic friction is a little bit lesser as compared to this. Is this clear? Is this clear, guys?
Yes, sir.
Always. Acha, so similarly there will be rolling friction as well. So rolling friction के लिए if I define this coefficient of not for any two given surfaces, for any two given surfaces, mu s जो रहेगा वो सबसे highest रहेगा, and then there will be this kinetic friction, sliding friction basically, and in the last there will be the rolling friction. Are you getting my point, guys? This is one of the very important results in friction. With this thing, the theory part is over. Only you need to discuss two angles, angle of repose and angle of friction. Only that is left in friction, and the questions are left in friction. So we'll start doing the questions now. Or shall I discuss the angles as well? The theory part will be completely over. Hello? Guys, do you want me to discuss the angles right now? Okay, let's start, you know, we'll do it later. Let's start with the question. Are you done writing this? Guys, are you done?
Yes, sir.
Let's do the questions. So suppose guys this block is of mass 2 kg, this block is of mass 5 kg. This is this table on which this 5 kg is placed is basically rough. The coefficient of friction between them is given to be, coefficient of static friction is given, like, the coefficient of friction between them is given 0 point. They have not mentioned whether it is static or kinetic, so you will take it as the static one, right? Hello? So how will you do it, guys? Can you draw all the forces? Can anyone draw all the forces which are acting on this 2 kg? Yes. Parinita, please tell me what are the forces acting on this 2 kg? Sorry.
Yes, mg is acting downwards.
So
2g.
basically 2g is acting downwards.
And there's tension.
Let's say the tension is T. Yes. What all forces are acting on this 5 kg? Tanish? Tanish?
Yes, sir.
Yes. Tell me what all forces are acting on this 5 kg block?
On what?
On this 5 kg block.
So tension or ये sigma u 0.2.
Is this a force?
सर सॉरी सर आई वाजंट कंसंट्रेटिंग मेरे पापा आए थे बोर्ड्स के बारे में बात करने के लिए तो मैं बात कर रहा था
Aman, yes, please tell me what are the forces acting on this 5 kg block?
Sir, friction, force,
Well,
gravity, and normal force.
so tell me whenever you tell force, tell me with the direction as well. Yes. So 5g
Sir,
downwards.
gravity of 5g downwards.
Normal reaction in the upward
And
direction.
then normal force upwards.
And what is the direction of friction? Acting on this block. Tell me. Towards left or right?
And sir, friction will be to the left.
Friction will be towards the
Sir,
okay.
Left.
The left is the
Oh,
correct.
wait, no, it will be right.
It will be towards right. Why it will be towards right? Why will it be towards right? See, can you see the driving force is basically the tension, right? External force which is trying to pull this block towards right is basically what? The tension. Yes or no? So this 5 kg block has a tendency to move towards right. So the direction of friction
Yes,
due to this rough surface is towards left. Case 1. Anna, is this clear, guys? So after this, what will happen? Now, can you see this forces will be bigger or smaller like this? So let's say if the question is to find the acceleration of the blocks, find the acceleration of the blocks, and second, the tension in the strings. So how will we do it? How will we do it, guys? We'll draw the free body diagram. Let us say this goes down with an acceleration A and this goes in this direction with an acceleration. Sir, why have you said like this? Because uske piche mein batata hu. So now see over here, guys, if this is moving, whenever you have any question which involves friction, the first step should be to calculate the value of limiting friction. And can you see, for limiting friction, you will need a mu into n, right? You'll need the normal reaction, right? Yes or no, guys? Yes or no, guys?
Yes, sir.
So for the normal reaction, you will have to draw the free body diagram, and accordingly, now your normal reaction equation will have certain. So this will be 0.2 multiplied by 5 multiplied by, let's take GS 10. So can you see this will be 1 by 2 to 2 by 10 to 5 10. The friction is basically how much is the friction? The maximum value of friction is how much? 10 Newton. Yes or no? Are high na? The maximum, the limiting value of friction is how much? 10 Newton. If I draw the now free body diagrams of 2 kg, this 2g will be acting down, t will be acting up, and this will be accelerating in this direction with an acceleration. Similarly, if I talk about FBD of 5 kg, then normal reaction upward, 5g downwards, and that is how we formed this equation, right? The second equation is basically this. So t minus 5g, oh sorry, my bad. So t minus f is basically m into a, because this was accelerating towards. So t minus f is equals to ma. F is given 10, and here it will be 2g minus t equals to, here it will be 5. Is this clear, guys? The two equations, two variables. Is it solvable? Acha. Can you see over here the friction? I'll write the whole 10 Newton over here. Ask me why. Because the object has come into motion. When the object comes into motion, you'll write the whole 10 Newton over here. So basically, it will become 10 minus t minus 10 equals to 5a, and this will be 20 minus t equals to 2a. Add both of them, you'll get 10 is equals to 2a plus 5a. 20 minus 10 is equals to 2a plus 5a. Adding. Solve कर रहा हूँ पूरा ऐसा. So this will become 10 equals 7. So A is equals to 10 by meter per second. Is this clear? So that's the answer to your first part. Now you just put this over here, you will find out the value of T. So T is equals to 10 plus 5 into 10 by. So what is 10 plus 50 by 7? 120 by 7. Is this clear, guys? Any doubt? Guys, any doubt in this thing? Please note it down. Please note it down. Just tell me wherever if you need to scroll up or down. Done. Guys, whenever done noting now, just tell me. I'll give you the next question. I'll give you an easy question. Shall I give you the next question?
Yes, sir.
Easy question. It is again an easy question. Suppose this is a wall. This is a very, strong wall, rough wall. So now this is a rough wall, and I have a block of mass 2 kg over here. Okay. Hello guys. This is mass 2 kg. I am applying a force F on this block. If the coefficient of friction, can you see I'm pushing this block against the wall. I'm pushing the block against the wall with a force something. I need you to calculate that force only. This is 0.3. The coefficient of friction between 2 kg and this wall is, if coefficient of friction between 2 kg and wall is 0.3, then find the force required. Then find the force required to hold the block at rest in this position. Shiroja, how will I start? Only the one thing which we already know, right? What is the only thing which we know? Don't draw friction. Friction always at the end. Just see the tendency and then draw the direction of friction. Okay. आज बैग निकालना बैग निकाल देते थे ना यहाँ से उठा के उधर एसी आता था ना हाँ जी बताएं how many forces are acting on this block? Can anyone draw the free body diagram of this 2 kg block? Yes. Who will tell me what is this thing? What forces are acting? Yes guys, who will tell me? Do I need to ask again? There is a 2g acting downward. There is a force acting in this direction. There is a normal reaction acting in this direction. and since this 2g will try to fall, make this object fall downwards, hence there will be a frictional force in the upward direction. Now we know this particular thing. Since this object is at rest, then this friction should be equals to 2g and n should be equals to f. This is your equation number 1. This is your equation number 2. Now we know this particular thing. Friction is nothing but mu n, because the maximum force, find the maximum force doesn't matter. So mu was given 0.3, n is equals to f, and that is equals to 2 into 10. So f will be equals to 20 divided by 0.3, which is 205. And that's the answer to the question. Anyways, it was an easy question. Just write it down. Done? Initial velocity is 0. The coefficient of friction between the block and the inclined plane is, let's say, mu. Okay. The block is gently pushed down an inclined plane. Pushed down from rest on an inclined plane. A block is gently pushed down from rest on an inclined plane with inclination angle theta. Angle theta, and if the block and incline have a coefficient of friction mu, then find the acceleration of the block. While coming down. Yes, please do it, guys. Let's say the mass of the block is m. Okay. Draw the three body diagram. Try to find out what is the acceleration. If it is coming down, that implies it is accelerating, right? Oh, the full limiting friction will be applied on that thing. Yes or no? Yes or no, guys?
Yes, sir.
So let us say at any general instant, this block is coming down with an acceleration a. So I'll draw this again for you. Let's say at any general instant, this object is accelerating with an acceleration a downwards. What forces are acting on it? There is this mg. There is this normal reaction acting perpendicular to the plane, and since this block is accelerating towards down the incline, hence there will be a friction up the incline. So basically these three forces are acting on this block, right? So if I draw the free body diagram, वापस से बढ़ा क्या? So FBD of the block this will be the direction of friction. This will be the direction of normal reaction, and this will be mg. So basically these were, and this block was accelerating down the incline with an acceleration a. So hence if I choose the frame of reference, will it look like something like this? Will it look like this, guys? And this angle was theta. So if this angle is theta, this angle is theta, only theta is out, this mg is out of the frame. So basically I'll connect it like mg cos theta and mg sin theta. Guys, are you even here? Ki sab so rahe ho?
Here, sir.
Hello?
Yes,
Yes,
sir.
sir.
So mg sin theta, mg cos theta. Now tell me, if it is coming down with an acceleration a, what will be the forces? What will be the equations? What will be the value of n? See, that this is what I'm asking. Are you people sleeping? Are you still here, or is it chal raha hai? What will be the value of n?
Sir,
MG
mg
cos-
cos theta.
तो बोलो ना यार. Why don't you speak up? Is it like you are waiting for me to tell you again and again like this thing? Now second equation. What is the second
Sir,
equation?
mg sin theta minus 0.3n is equal
0.3.
to.
Where is 0.3? I
Sir, I
didn't
know
give
the
any. I didn't
Oh,
give
sorry.
any mu. So
So
mg
then
sin
mu
theta
n.
minus f is equals to what? M into
ma.
A. So basically this bigger force minus the smaller force is equals to ma, and we know this particular thing, F is nothing but mu into n, right? Yes or no? So n is equals to mg cos theta. भाई लोग धीरे थोड़ा बात कर लो please. थोड़ा सा धीरे. And n will be equals to mg cos theta. So F is equals to mu into n. So mg sin theta minus mu into mg cos theta is equals to ma. Can you see m and m can get cancelled out. I can take g as common. So a will be equals to g sin theta minus mu. Is this clear, guys? Is this acceleration clear? Yes.
Yes, sir.
So basically this is the acceleration when it will come downwards, right? So, guys, I can ask you a question on kinematics here. Let's say if initially it starts from rest, if the length of the incline is, let's say, L, then find out the time taken by this block to come down to C. You will need this acceleration, right? Will you be needing this acceleration? Yes or no, guys?
Yes.
So this is all about that question. Now I'll give you one more question which is there on inclined plane. Okay. Suppose can you see an inclined plane theta, and this is a block of mass m. Okay, this inclined plane is fixed, it cannot move. Now the question is, if the coefficient of friction between them is mu, then tell me this particular thing, find the force and its direction to be applied on this block to slide it up to slide the block to slide the block up the incline slowly. But the slowly you need to you need to apply a force. Obviously the direction should be in to upwards the incline, right? Up the incline. You can either push it, you can either pull it, it's up to you. The second is to prevent it from sliding down. You need to solve this question and tell me what exactly is the difference between both of them. Hai, to prevent it from sliding down. So it may slide down a little bit, but you need to prevent it. Chalo. Always work on the tendency. Friction will always act where the tendency of an object is there. So it will always act in the opposite direction of that tendency. Okay. Try to do it. I'll just come in 2 minutes.
अच्छा कोर्स देगा तो अच्छी नौकरी मिलनी ही मिलनी है। तो वो आदमी नौकरी
Hello, sir. Hello. Am I lagging? Because I can't hear anyone or see anyone. Cyril.
Yeah.
Guys, done. See, what is the difference between both the cases? It's very easy. In one case, where it is to slide the block up the incline, so where is the block having a tendency to move? So in the first case, the block has a tendency to go up the incline, or if the block is going up, right? Whatever you can write. So the block has a tendency to go up. Just wait a second, guys. The block has a tendency to go up the incline. Hence, friction acts. What will be the direction of friction? Hello?
Sir,
So downwards.
So
Back.
mg here, normal reaction here. You are applying this force in this direction so that it goes up, and gently it goes up. Okay, so this should be the direction of friction. So if I draw the free body diagram, F acting in capital F acting in this direction, this is the small f, this is the normal reaction, and basically this is the mg. So mg will again be broken into two components, obviously, right? I'll choose the frame in which maximum amount of forces will come. This object is going up very gently, so you won't write acceleration and all, right? We'll just name it like this, theta, theta, and when I break the two forces, it becomes mg cos theta and mg sine theta. So can you see F and mg sine theta together? So the minimum force with which this should be applied so that it doesn't go up, it goes up, is basically what? Mg sine theta plus F, where what is F? What is F? F is basically equals to so this will be equals to M into G sine theta plus mu cos. Is this clear, guys? So this is the minimum force which shall be applied so that this object can be pulled up gently. Now second is basically what is the minimum force applied to prevent it from sliding down. So when the object has a tendency to slide down, tendency to go down the incline, friction will act. Where will the friction act now? I'm drawing this is the FBD only, na? N mg. This is the force which I'm applying over here. But since the object has a tendency to go down, hence the friction will also act upwards, right? So if I choose a frame, that frame will be like this, and hence again this angle was theta, so this angle will be theta. You'll again divide it into two components, mg cos theta and mg sine theta. So this will become how much? N equals to mg cos theta, and F plus F is equals to mg sine theta. So can you see over here, from here the minimum force will be equals to mg sine theta minus F. I'll just write the final result with you. F minimum will be equals to m into g into sine theta minus mu cos. So this is the difference in both the cases. Is this clear, guys? Please write it down, and that's it for today's class. You can go. Basically, no one seems interested. So everyone seems tired as of now. वैसे भी result भी आया तो कोई बात नहीं.
Oh.
Write it, please, and then you can go. Done?
Yes, sir.
Yes, sir.
Okay, we'll see you again in the next class, guys. Thank you very much.
Thank you, sir.
Thank you, sir.